Hi everyone. In this video we'll discuss about the functions. And this is a very important chapter over here. Let me define it. Say this is set A and say this is set B. Let's say the element here is X. Let's say the element here is Y. X is associated with the B as Y. And the direction is this. Important direction is here is important. Then we can write here as function F is A to B, because here function is dependent from A to B. Now function A to B is a function if every element, here every word is important, every element of set A is uniquely, here the important word is uniquely associated with set B. So two things are important here. First is every element of A is uniquely associated with set B. It means all elements of set A should be used to define, right? And should be uniquely associated with B. Now, let me give you an example. Say this is set A. Say this is the element 1. Say this is the element 2. So this is the element A. This is element B. Right? Now, this element A is associated with the A. This element is associated with the B. Right? Now it has only two element, has a three element. Now this is a function. Yes, it is function. Why? Because it has two elements. Both elements are used and both are uniquely associated with the set B. Right? Right. Now if I say this is set A, this is set B. Right. Now this is 1, this is 2, this is A, this is B. Now if A is associated with A and 2 is also associated with the A. Now this is a function or not? Yes, it is a function. Why? Because A and B, 2, 1 and 2, it has a two element, both the elements are used here and both are uniquely associated with the A. It has only one element A, one has only element A and 2 has only one element, that is same, that is A. So it's also one more example. Say this is 1, this is 2, this is A, this is B. So if I say set A has an image as A and B also. A is connected with the A and 1 is also connected with the B. One is connected with A, one is connected with B. No, it's not a function. Important thing is, so this is function, this is not a function, because one cannot have a two image, or one cannot is associated with the two elements of set B. One should be attached with the only one, or means unique element, uniquely associated with the B. So I hope picture would be clear for this definition, right? It means uniquely every element, and second is unique. Now let's come to the more about the vocabulary used in this. Y equal to fx. It means this is x is attached with the y, right? And it's called the function. Y is fx equal to fx. Now y equal to fx. So let's say y1 equal to fx1 is image of x1. In other words, we can say it's image of x1, or you can say x1 is pre-image of y1. Now this is important. X1 is image of y1 is image of fx1, or y1 is image of x1, or we say in the reverse, x1 is a pre-image of y1. Right? Now one more example. Say this is A, this is B, this is C, this is D. This is 1, 2, 3. This is set A and this is set B. A is associated with B1, B is with say 1, C is with 2. That's it. Is this a function or not? No, this is not a function, because D is left alone. D is not used here. D does not have any image with B, so it's not a function. One more method to define the function or is called the graphical method. This is somehow very important in the competitive exams. If you know the graph of the functions, you can easily judge it's a function or not. What we do here, if we draw a line parallel to y-axis and it cut the graph only at one point, then it is a function. The important thing in this definition or this line is, if we draw a line parallel to y-axis, if we draw a line parallel to y-axis, it cuts the graph only at one point, then it is a function, right? Now, if I say y equal to x square, do you know the graph of y equal to x square? Yes. y equal to x square. The graph is somewhat like this. If I draw a line parallel to y axis, if it cut graph at one point, then it is a function. Let me draw a graph, any line. Say I'm drawing this line. If I draw this line, if I draw this line, if I draw any line parallel to y axis, if it cut at only one point, then it is a function. Yes, it cuts only at one point. So y equal to x square is a function. Right? Now, second thing, y square equal to x. Now, if I draw the graph of y square equal to x, now you should be aware of the graphs here, right? The graph, you should know about the graphs here. So, y square equal to x, the graph is somewhat like this, right? It's a parabola function. If I draw a line parallel to y axis here, it cut the graph at 2 points, therefore, it is not a function. So, it's very easy to determine here. Third, y equal to root x. The graph. Now these two functions are not identical. Now we come to later videos. I'll tell you these two functions are not similar. Y squared equal to x and y equal to root x is different because now if you draw the graph is only in the positive directions. Because y cannot be negative here. Here the y can be negative. So it's a positive direction. If I draw any line parallel to y axis, it will cut the graph only at one point. And now important thing is this is a function, right? Third, y equal to mod sin x. Now you know all know how to draw the graph of sin x. Let me draw the graph of mod of sin x here. This is sin x. Actual sin x is like this, right? And if I use the mod word here, this negative part comes to the positive directions. I hope you know about the graphs. Negative parts come to the positive direction. Mod sin x is like this. So if I draw a line parallel to y-axis, any line parallel to y-axis, then I can say cut at only at the one point, therefore it is a function. And it is a fourth. Mod y equal to sin x. Now you should know about the graph here. You know the graph of sin x, right? So this is a sin x graph. When mod sin comes, positive part will be same and the negative part is eliminated. Positive part is same and the negative part is eliminated, and positive part is refracted with the x-axis. So this positive part is refracted because of mod sign here. Now this is this. Now if I draw any line parallel to y-axis, so this is parallel line. Now this line cuts this graph at the 2 points, therefore it is not a function. These are the few good examples through which you can judge the graph function. This is a function not using the graph. Where and watch for the next videos. I'll tell you about more about things about the functions. Before ending, let me give one more example. Fx equal to x square. This is a function, right? Now f is defined from integer to natural number. Important thing is integer to natural number. Y equal to x square. It's a function or not? Comment. Think about it. It's a function or not? F is belong to integer to natural number. Now here is we have defined the domain in codomain. Thing is y equal to x square and integer to natural number. For every integer, are we getting natural numbers? Y equal to x square is a function. We know that. For all the values, y equal to x square is a function. Now let's check for the integers. If I use any integer, minus 3 square is 9. Yes, it is a natural number. Minus 2 square 4 is a natural number. 3 square 9 is a natural number. Yes, it is a function. Think again. No, it's not a function because 0 has no image. Because for 0 square is 0 and 0 is not a natural number. Therefore, this is not a function because 0 has no image. So, that was another videos for more examples upon the functions. Thank you. Have a nice day.